Hello everyone and welcome to this next video in the series of tutorials for the Siemens NX CAD practical course. Today we are looking into assembly design and we're starting with a pretty easy example, which is not much easier than what you have to do in the exam though, at least in my experience. But I think I can show you most of the important functions that you have to know, even only with this design. And then for you, I recommend that you follow my steps in this video by doing them yourself. You can pause every time I did something new and copy me. And then to further exercise your skills in assembly design, you can either do this again. The parts, by the way, you will find in Elias and in the Teams folder. And or another exercises would be the two parts which are, or the two assemblies, I should say, which are in your technical drawings document. But I would say leave them until the end, so that the knowledge is fresh when you're going into the exam. Or at least do them now and then, or I'd say even better, do them now and also do them again before the exam. So let's get started. First of all, we have to click, as always, as if we wanted to make a model on new, but now we choose the second tab. We don't choose model, or the second option right here. We choose assembly, and I'm just calling this demo assembly, for example. Not too important for us. Clicking OK, and now you see we start almost the same as if we would have started a model, but now we have this window right here, and that lets us add the first components that we want to add to our assembly. And sometimes in this dialog, maybe it is here, you see I clicked on this little arrow, and here under loaded parts you would see parts that you have previously built and that are maybe even up here in your tabs. But for me, the parts are not here. For you though, in the exam, it might be something to consider because it's pretty convenient. But for us, and in all of the cases also in the exam, if you have saved them on your desktop or wherever in a folder, you can open parts here under open, and then I'm choosing these parts that we need, and I selected them holding control, or STRG in German, by the way, if you don't know how to do that. So hold control and then you can select them while clicking on them while you hold control. So now I clicked OK, and for you it might be on snap or something here, could be different. And if you go to WCS, then you see it will place your components around the place right here, and that's already okay. We don't have to do more, just click OK. And now we have our 1, 2, 3, 4 components here in our view. And next thing, the big thing we have to do is assemble them. And that can be done in this tab up here, if you look where my mouse is, under assemblies. And you can see there's not much here, not many functions, and we mainly need move component, assembly constraints, and maybe add component. In case you didn't open all the components so far, you can always go on add component and add a new one, just as we did before. But we already have all the components, so we don't need to do that. We only need to be concerned with how we want to assemble our parts. And first of all, what is this? What are we going to assemble? Well, I don't know what it is. It's kind of a rotor. I just designed it randomly to represent some of the functions that we need. But the idea is that this part should be in here. The ring should be on this cylinder, and it should be equally distanced to this surface and this surface of this rotor once it's stuck on here, so that it's exactly in the middle. And of course this rotor should be stuck on here. So that's what we want to do. And I would start always, that's important, don't forget it, by taking the first part, and I would say that's our first part because that's kind of the base, I would say, the biggest part. And we are using our first assembly constraint right here under assembly constraints, and that's the fix constraint, okay? And if you hover over the constraints, you always see a tooltip which explains the constraint pretty good, I'd say. And for fix, it says fix is an object at its current position, and that's exactly what it does. Once you have selected it, it wants you to select the object that you want to fix. I'm selecting that one, and now you see where I clicked, this blue icon came up. So I can click on OK, and now we have successfully fixed this part right here. If you want to see which constraints you have already done, you probably have to switch the tabs on the left right here. Usually you're in the part navigator if you come from modeling, and up here there's the assembly navigator, and here you see the different parts you have in the assembly, and you have this folder kind of that's called constraints. And if you click on plus, then you see here's the first constraint, that's fix, and it's for model 1. Okay, so how can we check? Well, we see that it worked basically, but we can also double check by clicking on move component, and now it wants us to select the component that we want to move. So I try to move this component, and before you can move it, you also have to click here on specify orientation. And now this thing comes up, and that's what you can use to move. Well, and I think it's pretty intuitive. With the arrow up, you could move it up and down. With that arrow, you can move it in the Z direction, with that in the Y direction. And these in between, these are rotating degrees of freedom. So here you can rotate it around that point in that direction, here in that direction. And as you can see, if I try to do one of them, if I try to drag one of them around, it always says you're trying to move a fixed component. So that worked. And in comparison, how would it look if we could move something? Let's show it with that one. I'm selecting it, I'm clicking on specify orientation, and now I can move it freely in space in all directions, and can also turn it in all directions. Okay, so I click on cancel so I don't have to move it. So that's how it would look if you could move it. And now basically in the end, our goal is that everything's only movable as intended. And this thing shouldn't be movable at all. It should just stick in here and stay there. So to do that, we can use one of these constraints right here. And I'd say the best one is that, touch align. And here you have multiple functions. I think usually it's on find closest, and I think you can leave it on that. And with that, we can let the part, or we can let surfaces touch each other. So my idea would be letting this surface touch this down here. Okay, so let's do it. Choose this surface, and it says select two objects, so I can directly click on another one, and yeah, that worked. That was the first constraint. But now you can see what this does is maybe not what you expected, because it doesn't look as if it would be touching, right? So to understand it, let's see what happens if we want to move the component. For example, can we move it in that direction? Yes, we can. Can we move it in that direction? Yes, we can. Can we move it up and down? No, we can't do that. And also, we can turn it if we want. So, maybe that already, some of you already understood how it works, that constraint. It doesn't let exactly this surface touch this, but it lets the planes on which the surfaces are touch each other. So these planes of the surfaces are on top of each other now, and we can't move it up and down anymore, but we can move this part on the plane on which this one is. I hope that makes sense. So we need to somehow restrict one more, at least, dimension of this thing moving. And for that, I would say we could let this face touch this one. And now you can see, okay, let's click OK, and to really understand what it did, let's try to move this one again. And you can see, okay, we can now still move it like that, but we can't move it like that anymore because that surface and that surface are now on top of each other, and that surface and that surface are now on top of each other, as we did in the constraint before. So the logic conclusion is we need to restrict one more degree of freedom, basically, and that would be gluing, so to say, this plane on that one. Okay, so let's use one more touch constraint between that and that. Okay, and now let's try one more time to move it. And you can see now I'm dragging this thing in the middle, which lets you move in every direction simultaneously, and nothing is moving anymore. So this part is now fixed. And by the way, this trying out where it moves is the reason why we need the fix constraint in the beginning, because if we don't fix that thing in space, then now I would have moved the whole two parts together, you know, because that one isn't fixed, and then that's glued to that one, and I would move everything, and then it's harder to see how it works. So for that reason, always fix your first part. Okay, so next thing I would say that we can do is sticking this rotor on this cylinder. You could now think, okay, we could use a touch constraint right here, but then how would we go on? Because we want this to be able to rotate, for example, and we want it to be exactly on top of that. And maybe we could do that with some weird combination of touch constraints, but luckily we have different ones for radial geometries. And the two most important ones here are concentric and align lock. And that's important that you understand the difference of these two, so please really try to understand them. It's not that hard. Concentric, let's read what it says. Constraints two circular or elliptical edges, so the centers are coincident, and the planes of the edges are coplanar. Okay, what does this mean? First words say we need circular edges. Okay, we have that. The centers are coincident, so the middle point of the cylindrical elements in our example of our circles should be on the same point. Okay, that's the one thing. And the planes of the edges are coplanar. That's kind of what we did before with the touch constraint. So let's see. We are selecting a cylindrical edge, that one for example. And now we want to select the edge, that's how I like to think about it, that should be exactly on this edge. And that's that one, right? Because this edge should be exactly there, and then this sticks on here. So let's select it. Okay, that worked, but as you can see, it's in the wrong direction. We want it different. And for that, we can use that little function here, reverse last constraint. If I click on it, you see, okay, nice. Now it looks exactly as we wanted. And now we have this constraint, which lays the center point on this center point, and the two planes on each other. And that already constrains everything that we need. And the important thing is that we can still turn this around the axis, but don't move it in any other direction. And also don't turn it right here, yeah? So we can only turn it around this, on top of this other circle, so to say. Okay? So that's one of the two. And the other one I can show you with this ring, because we want it to be on top of this cylinder. And now we can't use concentric anymore because, well, we could use that and that, for example, right? But now, if we reverse it, it's glued down here. We don't want that. We want it exactly in the middle, right? So now we can use align lock. And that says aligns two axes in different objects while simultaneously preventing rotation about the common axis, okay? So we can lie the center axis of this cylinder or this ring on the center axis of this cylinder. And a little tip, it's always a little finicky to get to the center axis. You can simply click on an element like this, and then it will automatically select the center axis. And also we can just click on this element. And now you see what the difference between this constraint and that one is. That one laid it on top of each other, and it allows rotation. And this one is kind of almost the opposite. It also lays it on the same axis, but it allows for moving, but not for rotation, okay? Okay, and now you might think, well, does it make sense that this ring is not able to rotate? Well, that should be part of the exercise. You should find that out, maybe just by logically inferring whether it should be able to rotate or not. But most of the times that won't be the problem why you won't pass the exam. So if it's in the right spot and does the right things, it's not a big deal if it turns or not. Well, for that one it would be probably, because of course that should be turning, but for the ring we don't know if it should be turning. Just in case, I want to show you how to make it, or how to lay it on top of the cylinder, but also allow for rotation. And we can do that again with the touch align, but this time we are selecting the center line, and also with that one. And now you can see, if we move that back on top of the cylinder right here, we can only move it in the direction, right? But now we can also turn it. It's hard to see, but you can see that it's turning, hopefully. Okay, and now our last goal was to make this constraint to be exactly between this and this surface, so exactly on the half of the cylinder. And for that we use a fourth constraint, and I think then the other ones aren't much important anymore, and that is center right here. And here you can center one part between two others. And you see you have different subtypes here. 1 to 2 would be if you want to center, well, I think I can't find an example with, maybe like that. Maybe you can choose that one. Let me try it. And then, so 1 is this geometry, and then 2 would be these two. And okay, now it kind of, okay, I see. I think that would center it, so that this point would be closest to that one, and this point would be closest to that one, if you know what I mean. And it would therefore turn the ring, which is not possible because we have already constrained it to be on this axis. So that was not the right choice, definitely. But in case you need to center one thing between two others, then you can use this, the 1 to 2. But most cases you need 2 to 2, I would say. And 2 to 2, here it is important how you select the surfaces. So we want to say, that's the idea, that these two should be in equal distance to these two, okay? So that the distance between that one and that one should be same than that one and that one. That's why it's called 2 to 2. And here you have to think, okay, 2, which are the outer two, these two, and now 2, 2. And I first selected that one, so I'm now selecting this one, and then this one. And now you can see it worked. It's not over constrained, it's not red. And if we try to move our ring now, we can't move it up and down anymore. We can only turn it. I hope. Yeah, there it is. And yeah, we are also turning that one for some reason now. But yeah, that's no big deal. So I hope that could help you. These are the most important constraints, in my opinion. It was a rather long video today, but I think that's basically everything that you would need for any exam. Let me just go through what we didn't cover in this video, because I can't tell you 100% that that's all you need. But for example, angle is something I've never seen. Bond, that might be interesting. So here you just constrain two elements to be a rigid body together, so they can't be separated anymore, like we did with that one with multiple things. But here you could do it directly, but I think using that is not very pretty way to do it. So usually the other constraints you can achieve bonding with a combination of other constraints in a better way. Fit, I have actually never used, so don't bother with that. Perpendicular, well, maybe that's interesting sometimes. Defines the direction of vectors of two object as perpendicular. For example, if you want to say that this line should be exactly perpendicular to this line, here you could do that. I don't know in which case it would be needed. Parallel might be maybe interesting. Here you could say, okay, this line should be parallel to this line. I don't know if it will be ever needed. And distance, here you can, maybe that's interesting. That would be a second approach to doing this here. Instead of saying it should be with the 2 to 2 constraint that we had, we could measure the distance between here and here, and then say, okay, that's and then specify this distance here as half, of course, minus the width of that, minus. Yeah, but in the end, the most important ones definitely are touch align, concentric, align, lock, and center, which I showed. And one more thing, maybe a little advanced. Under analysis, you have this thing right here, measure. And that's how you can also use this in your modeling overview, not only in the assembly. Here you can measure distances, for example, between this and this surface, as I said before. And now you see we have our measurement here, and it says the minimum distance is 180 millimeters. And that works for basically everything. You can just choose one line and it says, okay, the length of that is 100. Or you could even choose two surfaces like these two, and then it tells you the angle, the inner angle between them. Or you could choose like the cylinder, and then it shows you the area, the perimeter, the radius, where the center point is, and all of these things. That might maybe help you sometime when you're not sure if you did a mistake or something. Then you can see it by doing that. And one more thing which might be interesting in the assembly is under, let me find it, or maybe let me type it here, section it should be called. And it is under view and then section. Okay, let me see. View. Where is it? Okay, I can't. Maybe I'm just blind right now, but I can't find it here. It used to be here. So let's go here on the menu. You can always search it, of course, or click here, menu, view, and then section, and then you can do new section. And now you see you have this plane. You can say in which parallel to which planes of the basic coordinate system it should be, and then you can move it up and down and exactly see the cross section of your part. And like that you can check whether you have some gaps in between your assembly, for example, if you're not sure. But for me it looks perfect, everything, there's no gaps. Yeah, or whatever. If you think you have done a mistake, then you can see with this section view whether everything worked out. But I'd say for me it looks pretty good. Everything should have worked. And like that you can move the section in and out. It's a pretty cool tool. Maybe you can make some use of it. Okay, so that was it for today. I hope you could learn everything that you need from this video for assembly design, and we will, or at least you will, see or hear me in the next tutorial. Thanks, and until then, bye.